All right, here we are. Welcome, everybody. We're giving it 1 second for the broadcast to start here, and hopefully it should be happening soon. Let me double check. Give me 1 second. I don't know what's going on with the broadcast. First time setting this up, so always has to be issues that way. Let's see. All right, we are live. That's great. Okay, well, thanks everybody for jumping in. This is going to be a fun talk today about ADBC 14. This is a interesting release, so what I'm going to do in this is just kind of give us a high-level overview of some of the features. I've listed them here in the order that we're going to go through. And yeah, as you can see, not all of it's production ready just yet, right? So some of this is to give you an idea of what's coming on in the future, and there's some limitations to what's being done here, but I'm really excited about this. I think ADBC is a great technology. I just want to keep spreading the word because, 6 months, a year from now, as these features continue to improve, it's like the foundation is there to replace ODBC and JDBC in a lot of instances. Just needs a little bit more time and development. But I want to, again, spread the word and get people excited about it and give you, the users, a little bit of an advanced look into what's going on with ADBC. So with that said, let's go ahead and jump into some code. And we're going to start looking at BigQuery here for a second. So if you've used BigQuery before, with a data frame, you've likely used some combination of, maybe you use the ODBC drivers that they have. They do exist. I think more people are probably using something like Pandas GBQ to take data frame data and write it to a BigQuery database, or the other option is maybe in your ETL process you have something where you're taking your data, dumping it to Parquet, and uploading those Parquet files to BigQuery. All those options I think are viable for different reasons, but still less than ideal. When you're talking about something like Pandas GBQ, it's pretty heavily tied to Pandas, which may or may not be a bad thing depending on your perspective, but it's always good to have different options. And of course, with the Parquet feature, you're taking data that you probably have in memory, writing it to disk, moving those files around, and then pushing up to a database. So it just adds some disk storage costs, some extra steps, extra failure points in your ETL process, or if you had an ADBC driver, you wouldn't have to worry about that. Now, up until the ADBC 14 release, that was not an option, but we are starting to see a BigQuery release come out. One thing that's interesting is right now for ADBC 14, this BigQuery driver is not available on PyPy, so I would expect for the next release, it's going to be available on PyPy, and also have some of the features that I'm going to show you here that aren't quite working yet. But again, this is to kind of give you an insight into where the library is headed and hopefully get you excited about what's going on. So with that, I'm going to go ahead and activate a environment that I have called YouTube demo. And I'll post as well the environment file I'm working with later on after this video. But basically, I've installed the ADBC BigQuery driver. So if we were to look at that, I'll go ahead and import that ADBC driver. Let's do BigQuery. And let's check the version on that driver, BigQuery.version. So I'm using 1.2. Again, not on PyPy, only conda for now. But check it out and use it. And yeah, so when it comes to BigQuery, and I guess any database, you have a driver. The driver is typically easy to install. The database itself is a little bit more difficult to set up. So I didn't want to go through that on this video. That can be an entire video in and of itself. And for a live demo, I didn't trust a cloud deployment to really work all that well. But there's a couple things that I have listed in this README that you need Number one is the gcloud CLI, so you can see the documentation on that and just kind of install it on your own. The other thing that I've done that's optional, but I would highly recommend, is just to use Terraform to deploy this. So we're not going to go over Terraform here and how it works, but even if you don't use Terraform, it can help outline a few of the things that you need to use to make this a possibility. Number one, I'm setting up a fresh project, calling it this project ID. So if you use this code on your own, just change your project ID and billing account. After the project, you need to enable the BigQuery storage API and the BigQuery API if they are not already available. And then last but not least, you need to actually set up a BigQuery database. So again, what I like about Terraform is I can come in here and just say Terraform plan, Terraform apply, and it will auto-create that architecture. If you already have something set up, you may not need that, but if you're starting from scratch, I think it's very helpful to get started. And we're just going to use application default credentials. So there are quite a few ways to do that. You can use service account credentials. You could probably use username and password. But the application default, I think, is pretty simple amongst all the options. And again, that's kind of managed by gcloud. So anyway, all those things aside, I have this set up. Let's even look at what I've deployed, right? So if I were to jump into Google Cloud and check out this database, we'll see that there's not much in it right now, right? So I'm jumping to BigQuery, and in this project, I have a demo dataset. So if you aren't familiar with BigQuery, dataset schema, kind of similar. So I will kind of use those terms interchangeably. Coming from a Python perspective, we pretty much almost always refer to these as schemas. So let's take a look at some example code I've written to interact with this database. Now, I've picked or I've chosen to just use PyArrow directly here. Again, this driver is a little limited right now, so I didn't want to get into some of the nuances of how pandas or polars interacts with all these drivers. PyArrow is kind of the most basic. So let's just take a look at this code really quick. I'm going to go ahead and start by just importing this in the IPython. Nothing too crazy with the imports. I'm just importing the BigQuery driver and its DB API, essentially what Python wants to interact with databases. BigQuery has these database options, which is a little bit different from some of the other databases that you work with. I'm not sure any of the other ADBC databases have actually used those, but maybe that'll change in the future. And the rest of the imports are PyArrow pandas. Next, I'm going to actually set some of these options, right? So I'm saying the name of the project that I'm working in, which was created actually back in my Terraform module. As you can see, tweak that as needed. I've created the dataset as demo dataset, and I want to create a table just called foo. Again, as you need to, just kind of tweak these. And last but not least, what I'm going to do here is just create a table of data. So this table, I don't know if we kind of look at that in a pandas perspective, it looks something like that. I just have integers 1, 2, 3, and these decimals. But the decimals are actually a decimal data type, which is nice. I want to see this kind of get preserved. If you've used dataframe libraries in the past, especially with SQL, you've probably seen decimal is not something that usually gets maintained, gets turned into double precision a lot. So with that, typically, and you'll see some comments here that I've added about features that are missing right now. One is a bulk ingestion mode in BigQuery. So typically, you could work around inserting data in a few ways. One is to just have like a bulk ingestion method, which is usually the fastest option. You know, if you're familiar with Postgres that we'll talk about later, that usually means you're copying data into a database. The bulk ingestion is really high throughput. The other option is to create a prepared statement that kind of gets the database ready to insert values, and you keep kind of adding values to that insert statement as you run it in a loop. That option's a little bit slower, but still faster than not preparing a statement. So that's what we're going to do here. Again, because it's the only thing that works at this point in time with BigQuery. Maybe by the time ADBC 15 comes out, we'll have bulk ingestion. But just to give you the advanced preview look, what I'm doing here is starting a context with this context manager, which is taking the ADBC driver BigQuery, connecting to the DB API with the database keyword arguments that we defined above. That's set with a project name, dataset var, ID, whatever. And then I'm going to get a cursor out of that as well within my context. Once I have the cursor, I can do a couple things here. I can go ahead and create this create table if not exist statement, which is going to create the table. I'll prepare the statement that I'm going to use for insertion. I'll actually execute that same statement using the table of values that I have, and then I'll commit the transaction. So through these steps, as you'll see, I'll go ahead and run this. And once it's complete, I'm going to go back to my database in BigQuery, and you'll see that this now shows up. Let's go ahead and refresh the contents. I have the foo table, right? So I've written directly to BigQuery from the command line here using just the ADBC driver. And you'll see when we actually select from this that we'll get the results that we wrote. And with the same data types, right? I have these are decimal and these are integers. So I was able to maintain that throughout, which is nice. Now, when you're talking about reading the data back, it's a little bit easier right now. We don't have to worry about the bulk ingestion or prepared statements as much. So actually, to get this back to a data frame, now that it's in a BigQuery table, I'm just going to use this, which is kind of the pandas syntax for connecting and reading from a database. Basically, I'm creating that same connection, and I'm going to create a SQL statement that reads from that project name, data set, and table, and uses the connection that I'm going to open. So the reading side right now is a little bit more feature-rich than writing. If you just run this, I'll get the table back that I kind of started with, but with all the data types that I actually want. So I specifically chose with pandas read SQL to use the Arrow backend because I didn't want pandas to change anything to an object, which happens a lot. So when you're working with ADBC, the Arrow backend is a pretty good option. And you can see, again, I've gotten in 64. I'm not getting double precision, right? I'm maintaining the decimals. Now, the precision and scale values did change. When we started, I created a decimal that had a precision of 10 and a scale of 2. BigQuery doesn't, as far as I know, have different precision and scale options. I think they just give you 38 and 9 when you use a decimal object. And I think they have big decimal that maybe is like 72 and something else. Don't quote me on those numbers. Check the documentation. But this isn't entirely lossless, right? The precision and scale are not going to be maintained going from Arrow to BigQuery. So there you go. That's the BigQuery integration. Now, again, think about this replacing, potentially in the future, any use of pandas GBQ or any use of Parquet files that you're managing on your own. It just will help simplify the process. We're not going to go into performance tuning here. I've talked about performance in the past, but ADBC is very fast. So if you were to run benchmarks against your BigQuery database, I think you'd see that it performs pretty well. So that is BigQuery. If you have any questions, feel free to type them in the chat, and I'll be happy to answer them. But for the time being, now that we've gotten BigQuery out of the way, let's switch gears a little bit and talk about Postgres. Now, what's funny is, well, I guess not funny, but when I wanted to do this video, I had in mind showing all these great features that just kind of worked out of the box. And then when you go through the implementation, you start to see the rough edges of the implementation. So there's still a couple things here with Postgres that I found with ADBC 14 that weren't entirely working. So I actually had to install a newer version. So I think I'm giving you a little bit of a sneak peek into ADBC 15, what's coming next. So apologies, you won't be able to get these today. directly if you wanted to from PyPy. But you'll see if I were to go ahead and import ADBC driver, let's go ahead back to PostgreSQL, and I look at the version of PostgreSQL. Whoops. I'm going to have a development version here of 1.3 dev, right? So I think 1.3 is going to be ADBC 15. I'm not quite sure how those versions are managed right now, but yeah, this is not quite available in PyPy. If you did yourself want to get a sneak peek into that, you're certainly welcome to. I would advise with Arrow ADBC, they have a Python folder in the project, and with each of them, there's like ADBC driver Postgres. You can check the README. So I don't know. I don't think this is entirely all that difficult, but it really depends on your background, right? If you're just coming from Python, you're probably not used to building applications from scratch. But if you have some background in C, C++, if you use CMake before, you can really just run these two commands, and actually this documentation is a little bit outdated. I actually fixed this on main. So check out the latest documentation on main. It should look something like that. You can just run those two commands from the root of the project, and we'll install a development version of Postgres driver for you. We're not going to do that now. Again, this is a demo. Less failure points is always better. But let's go ahead and talk about JSON support for now. So what I've done with Postgres, and also taking a step back, I guess the first thing you want to do with Postgres is get a Postgres database available. Not going to go through that here. You can use whatever is set up on your system, or if you don't have something, Docker is an easy thing to use. So I'm actually going to run a Docker image on my end. And as you can see here, I've given some commands that are a quick setup. So I'm just going to use pSQL to log into this and make sure that this is good. And using my password as my secret password. I just copied that from Docker. And if you look at what we have set up right now, I'm starting with this Arrow commits table. So this was taken from Dewey Dunnington's post on the Arrow ADBC issue tracker. So I'm not going to take credit for this data set, but I thought it was really nice. If you take a look at this one, whoops, select all from Arrow commits. It's JSON data, right? So you can see each record has a record of like time, files, merge, commit, and message. Okay, so within, and you can even see that same data type here on the table, sorry, JSON-B, binary JSON. So within Postgres, if you're not familiar with this, you do have some ability to look at individual elements of a JSON array. So let's say I just wanted the commit from each of those. I could use that kind of syntax, right? Data with the kind of arrow over to the column that I want to extract. In this case, it was commit. I could have also done, time. So you could set up your select statements to extract components this way. Certainly a viable option. But we could still do a little bit better. I personally like working with this kind of data in a dataframe library. I'm sure Postgres has great features for it. I'm just not super familiar with them. So there's some basics. You can look at the rest on their documentation if you want to. I'm just going to jump right into getting this data out into a data frame. So I'm going to import a few things here. This is the Postgres driver we were talking about. We're going to use pandas. And then I'm also going to go ahead and use that same information that I had before. Now, don't be like me and put a password that's really actually useful in your code. Please do not do that. This is just a demo. And again, I'm using the basic Docker image, so I'm not really worried about security here. This is not accessible outside of my computer. Whoops. But yeah, that's your setup. You get your connection string information. And then with pandas, you again just read here to get the data. Now, what's going to be a limitation of the JSON integration right now is it doesn't really read data back as pure JSON. There is a JSON type in the Arrow specification. I'm not sure if it's first class or an extension, but it does exist. It just isn't really implemented in a lot of places yet. So this is something I think may change in the future. You may see a future where you get back a JSON data type from ADBC, but for now, what ADBC does is take JSON that you've read and pull it back into a string. Likewise, if you were to try to write, you'd want to write a string and leave it to the database to kind of convert that to JSON for you. So it's not as easy as some other types, but you can read it again into a string, which can yield some other interesting usability features. So one of them, this is kind of a workaround, and using pandas syntax, which I find a little bit strange. Whoops, let me go ahead and import PyArrow. What I'm going to do is just take this JSON data. I've looked at it. I've seen that it's basically just a top level dictionary. Nothing's nested. So this works pretty well with a struct data type in Arrow, right? So I can create a struct type that has commit, files, merge, all those same things we just saw, but as individual fields. In pandas, I don't know why, but assigning arrow type creates an object data type, something I hope to improve in the future. But for now, to make sure we really have the arrow data type that we want, I'm going to go ahead and do this PD arrow D type, arrow D type thing here. Polars might have a better way of handling this. I'm not as familiar with polars. I'll show you some polars in this talk, but I'm definitely not an expert. So that's how you would do something like that with pandas. But once you actually have that field in a pandas data frame, you actually can unlock these struct fields, right? So if I wanted to extract the commit field from that, I could do something like that. Just say within my, I probably should have called this JSON, but the array that I just added, it's a struct that I've created, grab the commit field. I could change that to time if I wanted to, grab the time out of that. Or maybe what I could do as a last thing here is just explode that kind of JSON data into something else. So, whoops, what is going on here? Data types, yeah, that is not the right command. Let me come back to that. It should be df.explode by the array column. Still missing, sorry. R.struct, what am I missing here? Struct explode, okay, I was missing the accessor, sorry. So if I treat that column as a struct and I call explode, I kind of get a data frame that's taken all of those individual struct elements and extracted them out into their own table. So these types aren't widely used just yet in pandas and I think in general, but what I'm really hoping that you'll see, and especially by the end of this, is I think there's historically been this thing where you do a lot of data modeling to take semi-structured types like JSON and Array, and you kind of normalize them, you clean them, you put them into different tables in a database. While that's not going to stop today, at least for JSON types, I think there is a future where you can just more naturally store your JSON data kind of inline, right? You get this all the time when you work with, I don't know, a REST API that maybe is coming from a MongoDB database or some other kind of NoSQL database. I mean, it's not uncommon to have kind of records and then each row gets JSON with it. There is a future where you could just store that JSON in a database like Postgres and kind of work with it naturally instead of having to do the modeling up front, which I think is really nice. So that is Postgres. Let's take a look next at unsigned integer support. This is going to be super quick because I think this is a very simple feature. But this time around, I'm actually going to use polars just to show you how other libraries can work with ADBC. So let's go ahead and get polars imported. I'm using the same connection information I had before, and I'm just going to go ahead and create a very small data frame here. And this looks something like this. So it's not an interesting data frame, but it does have unsigned integer types, which for reasons actually I'm not sure. Databases do not typically support unsigned integers. I'm actually not aware of any. So the idea here is even though we have a type that exists in Arrow that doesn't exist in databases, Arrow is going to try and find the best fit for it. What you'll see, there's the polars. They use Write database as their API. If I come back to my database, you'll see I have an unsigned ints table with all the same information I just started with. And if you look at that, the data was stored as a small int, integer, and big int. So you can't round trip this type of data frame losslessly. You're going to lose something with the data types. But you know, there may be a case where you don't want to deal with this stuff kind of manually. ADBC will do the next best thing and just give you those integers kind of upgraded to a size that can fully contain it without losing any information, and that will be the next size up signed integer option in the database. That is unsigned. We're not going to spend a ton of time on that because as I said, it's pretty basic, so there's not a ton to say here. But this last feature is one of my favorites, and again, I think will be paired well with JSON. Now, this is really feature complete in my mind for Postgres. The ability to use list and array types. I think they're called arrays in the world of Postgres. So same thing, let me grab my URL. I'll drop that in here. And once again, I'm just going to start with a Arrow table. I don't know, this could be some kind of HR system, right, of employees at a company and who their direct reports are. So again, historically, if you were to do something like this, you probably have a separate table that would say like direct reports or hierarchy, whatever it is. Here, what we're going to do is create 3 users, John Smith, Jane Doe, Jimmy John, and in line here, I'm going to add a column called direct reports that basically tells you that Jane Doe has 2 people reporting to her with ID 0 and 2, essentially the other 2 people in this table. So we'll go ahead and create this as a full Arrow table, see what it looks like here. Let's go ahead and, yeah, I guess push into pandas looks a little bit nicer. So this is what our data looks like in data frame form. Now, what we can do here is just go ahead and grab this, and I'm going to write this data from the table into Postgres. Now, a contrast here again to what we saw with BigQuery. When we were looking at BigQuery, we could not use the ADBC ingest method of the cursor. We kind of did the prepare, bind, execute loop. If you get bulk ingestion, it's a lot nicer. So we do have that feature here. We're going to use it and just take the data that we have in our Arrow table and push it to the employees table. Go ahead and run that. Super simple. And yeah, now if we look at our employees table in the database, you'll see exactly what we had in our data frame, first name, last name, direct reports. And there's a lot of functionality that you can kind of do here. I don't know as much on the Postgres side what to do in terms of dealing with data, but I do know with pandas, you get some cool options, right? So I'm actually doing this on the fly. I thought I had this prepared, but we'll go ahead and just kind of wing it. If I were to read this back into pandas, I would do something like PD read SQL, and I'll go ahead and do select star from employees table. Give it the name of the con. And once again, I want to stick with Arrow data types in my pandas data frame. So I'll run something like that. I've completely round tripped the data that I got from the database, and I have this direct reports column that shows you, again, that same information. So just like we saw with struct types, this is a little bit pandas specific. Polars will have their own syntax for dealing with what are called aggregate types here, structs, lists. But in pandas, you have this list accessor once you have a list data type. So I could say something like, grab me, the first or item at index 1 in every list. If there is no value, it'll just kind of come back as NA. You see that kind of works. But the other thing you might want to do is just take this data frame and explode it by that column, right? So I could say direct reports. And now I have a totally new table that is telling me kind of that flattened hierarchy. So this is something that you may do in your own reporting. to get this. You lose the uniqueness of the names, but now you can kind of see, that Jane Doe has 2 direct reports, right? So it really depends on the analysis that you want to do, whether you want to kind of explode this into this long form like this, or keep it in its bare form, where you just get that information in the direct reports column. But in any case, that is how list data types work. I'm really hopeful that this can change the way you have to model. Again, I've seen a lot of data modeling where you're doing normalization up front, you're cleansing data, and while there's nothing wrong with that, if you could store it more naturally in a form like this, using list data types, JSON data types, and if the driver supports it natively and performantly, then just store it that way. Keep it as kind of untouched as possible and leave it to the analysis tools to kind of do the heavy lifting. And I think that just makes the process so much easier. Cool. So that's pretty much the main features I want to get through in ADBC 14. I'll gladly answer any questions that come up in the chat. Otherwise, we have a little extra time. I can just kind of drive home, I guess, some really nice things about ADBC in the past few minutes. We've talked about in this kind of small samples. I didn't want to overload with these huge data sets of JSON data and list data, but hopefully this is a good foundational building block for you. I don't know. Let's see if we have. Do we have any big data sets laying around? I don't know that I do. No. So yeah, I don't know. We'll skip on the performance for now. If you want to see performance, check out my talk on YouTube from PyData 2023 entitled Pandas with ADBC, something along the lines. I should know the name of it, but yeah, it's an exciting tool, great technology. Thanks everyone for joining the chat today. And if you have any questions, feel free to reach out to me, and I'd be happy to answer them.